Hi, my name's Chris Webb, and in this video I'm going to show you how you can use Microsoft Power BI to analyze road traffic accident data. My starting point is the UK government's Open Data Hub, data.gov.uk, where I was able to download a series of zipped up CSV files containing information on all of the road accidents that took place in Britain between the years 2005 and 2012. Once I'd unzipped those files to a single directory, I was able to move to Excel and start using Power Query. Now, Power Query makes it super easy to take a directory full of identical structured CSV files, such as the one I've got here, and then combine all of those files into a single data set. And that's what I've got at this step. Next, all I need to do is take the first line of data and treat that as the headers. Change the type of some of the columns, remove some columns that I'm not interested in using, and then finally load this data to the Excel data model so I can start using Power Pivot. Here in the Power Pivot window, you can see the three large tables that I loaded through Power Query, and also a lot of smaller lookup tables that I loaded directly from an Excel spreadsheet that came with the data. I've created some relationships between the tables. I've done things like hide some columns, and you can also see a hierarchy here that I've created on the date table. Here on the casualty table, you can see some measures that I've created. For example, this one here counts the number of casualties. And I've also got a calculation here in two parts that allows me to see the year-on-year growth in the number of casualties expressed as a percentage. And I've even created a KPI on this that will allow me to see very easily in a visual way whether the year-on-year growth is good or bad. Let's take our data and analyze it in Excel. Here's an empty pivot table. And I'm going to drop my casualty count measure into it so I can see the total number of casualties and break that down by year. Not very interesting on its own, so why don't we insert a chart? Now it looks from this that there is a decline year on year. So let's add a trend line, and yes indeed, it looks like there's been a decline year on year in the number of casualties. Let's have a look at this data by age band. I'm going to insert age band as a slicer. And now we can slice our data by age. If we look at the over 75 age band, you can see there's been a very big decline in the number of casualties. Whereas if we look at the 56 to 65 age band, there is actually a much less marked decline. And we can of course use that year-on-year growth measure that I created earlier. There are the percentage values, not very helpful just to look at the values. So let's have a look at my KPI, and we can see at the year level everything looks great. We've got a very good decline in the number of casualties year on year. But if I drill down and I have a look at the year 2011, very quickly I can see that there were 2 months, January and December, where there was a very big spike in the number of casualties, and here in December we've got an almost 21% spike in the number of casualties year on year. Of course, pivot tables and charts are not the only way that we can analyze data. On this sheet, I've got a heat map created using Excel cube formulas and conditional formatting. And along columns, I've got my days of the week, and on rows, I have the months of the year from 2010 to 2012. From this, it looks quite clear that if we're looking at the number of casualties, Friday seems to be the most dangerous day to drive. But if we slice the data so that we only look at fatal accidents, the pattern changes, and you can see it seems like the weekend is probably worse. I wonder if age band has something to do with this. If we look at the 16 to 20 age group, there's no clear pattern. But as soon as we go to 21 to 25, where people are old enough to drink and drive, you can see that now it's the weekend, Saturdays and Sundays, that seem to be the most dangerous days. And that continues in the 26 to 35 age group until we get to an age where we're a little bit more sensible. And here, in the 56 to 65 age band, we have no pattern again. I can also use a PowerView sheet in Excel to visualize the same data. What I've got here are a number of stacked column graphs, again showing casualty count, broken down first of all by age band, and then each of the multiples here shows day of the week. If I start slicing the data by casualty class, I can see some interesting patterns appear. If we only look at casualties where a person was a passenger in a car, we can see there is a clear spike in the 16 to 20 age band, maybe when people have just learned to drive and they're taking their friends with them. If, however, we look at people who were pedestrians, there's another clear spike, but this time it's in the 11 to 15 age band. Now, maybe these people are school children. How can we test that hypothesis? Well, here's a blank PowerView sheet. Let me take casualty count, and now let's break it down by hour of day. If I take this and I show it again as a stacked column chart, and let's break this down by day of week, and we slice by casualty class, pedestrian, and age band 11 to 15, there are spikes. Now, where are the spikes? They are at 8 a.m. and 3 p.m. when children are going to and from school. And we can confirm this hypothesis by dragging month name in here. And if we slice by August, when there's no school, there are no spikes. If, however, we slice by September, when everybody's back at school, the spikes are there very clearly. Finally, let's see if we can use PowerMap to look for particularly dangerous sections of a road. What I've done here is I've isolated all of the data for the M4 motorway, which stretches between South Wales and London. And what I've also done is I've divided the motorway up into very small sections. So instead of looking at individual accidents, we can see aggregated totals for the number of accidents on each one of these small stretches of road. When we plot this using a column chart, we can see very clearly that the biggest spike is towards London. And if we zoom in, we can see where that is exactly. And unsurprisingly, it is at the junction of the M4 and the M25, one of the most busy sections of the road in the whole country. Interestingly, it's not exactly on the junction, but it's about half a mile before, perhaps where people are manoeuvring for position. Of course, this is, though, one of the busiest sections of road. So maybe the spike here is something to do with that large amount of traffic. If instead we weight the number of accidents by the amount of traffic on the road, and I was able to do this by taking some more open data from data.gov.uk, we can see there's still a spike, but if we zoom out, we can see that actually the most dangerous section of road is in South Wales. And to be precise, it's at junction 41 near Port Talbot. And that's the end. Thanks for watching, and I hope you've seen just how much fun you can have using Power BI.